Hi everyone. Okay, so I just want to review the four postulates we've been looking at for these past 2 weeks. So these are all uh, postulates or theorems we can use to prove that two triangles are congruent. So you know in the past where we have to find all the angles, all the matching angles, all the matching sides. Well, with these postulates, these four ones right over here, we don't need to do all of find all the matching angles, all the matching sides. Instead, we can find these specific combinations, and these only work with triangles. So up here we have the side, side, side postulate. What's going on over here, if you're able to find three matching sides, you can just say the whole triangle is congruent. You don't have to go in and find all the matching angles as well. For side angle side postulate, you just have to find those two pairs of matching sides, and then that angle, those one pairs of matching angles that are in between them, right? So when the angle is in the middle of or in between the pairs of matching sides, then you can use the side angle side postulate. So those will also allow you to prove that the whole triangle is congruent. Next, we have the angle side angle postulate. So that's just saying if you can find two pairs of congruent angles with the matching sides in the middle of those congruent angles, then you can say the whole triangle is congruent. And then over here, angle, angle, side postulate, this is just saying when you have two pairs of congruent angles and you have that matching pair of sides, it doesn't have to be in the middle of the angles. It could just be in the side like that. You can still say that these triangles are congruent, right? So you can use this time to pause the video at any point to reread the exact definition, but that's pretty much what these four postulates were saying about congruent triangles. Now let's move down to some questions over here. So here, for the following triangles we're going to look at, we have to see if we can prove if these triangles are congruent. This should have just said B. So here we're working with triangles JKL and NML, right? Those are the two triangles we're working with. Now, whenever we want to prove congruence, we want to be very exact. So let me just make some marks. Okay, so over here, going by those little red lines and the curves, KJ is going to match with MN. So let me just write that. So KJ is congruent with MN, right? And then over here in the corners, in the angles, they're telling me that angle K matches with angle M. So let's go ahead and write that. Angle K is congruent with angle M. And then that's all the information they gave me with the red marks. Now, over here, you can see that these triangles are attached to each other. So we can actually use the place, we can actually look over here in this middle part. So let's look at it. It looks like we have angle MLN, right? And then we have angle KLJ, right? So those two angles here. So, oops, yeah, those two lines. So notice how these two angles, they're what we call vertical angles. So what we know about vertical angles is that they're also congruent. So even though they didn't tell us that, they didn't give us those little curves or lines, just by looking at the way they're attached, we can also find congruent angles. So we have KLJ, that angle is going to match or be congruent with MLN. And the reason why is because they're vertical angles. All right, this only happens when you have triangles that are attached to each other. So now let's see over here. We have a hold on. We have a side, right? We have angles and another angle. And we want to see where they're all placed together. So we have the angles right next to each other. So see this little double thing and this green angle? They're right next to each other. And then you have the angle on the side. Well, if you look back at those postulates, we can actually use angle, angle, side. So here we can just say triangle JKL is congruent with triangle NML because angle, angle, side postulate. And then we're done. All right. Let's look at another example. So down here we have triangles PQR and then we have TSM, right? So I know that they're kind of flipped over. So let me just redraw this TSM right down here. TSM, those little notches. Okay, and now we have to see what type of, if they could be proven as congruent. So let's just work with what they gave us. So they have QP, oh sorry, yeah, QP and TS, right? So again, we're looking over here if we have this upright. And then we have QR with MS. So let's just write these these side pairs. So we have QP matches or is congruent with TS. And then we have QR. Oh, these are all sides. QR is congruent with MS, right? And then over here, let's make this pink. Over here in the middle, we have that angle Q and S. They're both have that mark. They're both right angles, so we can say that they are congruent. So angle Q matches with angle S, right? So let's see how they, oh yeah, so over here we have a side, you have a side, and then we have an angle. So let's see how they ordered it. So it looks like we have two sides on this, all right? And then in between we have that angle. So with this, we can actually say triangle PQR is congruent with triangle TSM because of side angle side postulate. The common or the congruent angles are in between the congruent sides. So we can use SAS, right? That A is in the middle of the S's. So let's look at this one down here. So again, we have two triangles. They're meeting at this angle. So let's see what we can work with. All right, so we have line EF matches with HJ. So let's go ahead and write that. Line EF is congruent with HJ. And then we have line FG matches with GH. FG is congruent with GH. And then over here, we have those angles, right? So let me just erase these so you can see it. So we have H, G, J, and then we have E, G, F. So those two angles are across from each other, right? And they're making this X mark. So we can say that these two are, they're making that X mark, so they look like they are vertical angles, which, yeah, they are vertical angles. So what we know about vertical angles, they're congruent. So E, G, F is congruent with H, G, J. All right? So it looks like we have a side, we have another side, and then we have an angle. So let's see how they set this up over here. So let me just erase this again. So you have the sides that are next to each other, and then you have that common angle right over here. But the thing is, we have side-side angle. So side-side angle, oops, is, yeah, side-side angle is not one of the postulates we learned about, right? We can't have two sides together with an angle not in between it. So what we're going to say here is not enough info. And we'll just leave it at that. We can't really say, we can't say that they're congruent because of the way everything was placed. Now, if they said angle F and J, F and H, right? Sorry, F and H were congruent, or matching pair, then we could say, oh, SAS, we can use side angle side here because these angles are in between the matching sides. But they didn't, so we can't use that. All right, so let's move down. Okay, so now we have something like this. So we still have two triangles that are stuck to each other. So again, we're going to go ahead, get our highlighters out. WX matches with XZ. WX is congruent with XZ. And then next we have WY is congruent with ZY. WY, it matches ZY. Okay? And now let's look right over here. They're both sharing this common side, right? This this XY. I mean, if we were to go ahead and cut them apart, so let's say we have over here, this is WXV, right? Oh, so XY, and then this is YXZ, right? If we were to cut these triangles in half right over here, like unstick them, right, just take them apart, you see that they both share that XY side. So without them giving us notches, right, without them giving, oh, hold on a second, without them giving us little lines, right, we were still able, sorry, they gave us this side. Yeah, we're still able to say that these lines match, these lines are congruent because they're named the same. So this is what we call our reflexive property, right? Reflexive property. So we can say that XY is congruent with XY. They have the same letters, are named the same, so they will be congruent. So here we have a side, oops, a side, and a side. So we can say that triangle XWY is congruent with triangle XZY, right? Because of the side, side, side postulate. And then we're done. Now let's look at this last question over here. This is saying, what additional information do we need to prove that two triangles are congruent using the attached postulate? So basically what this is asking is, we want to use the Asa congruence postulate. But the thing is, this is the only information they gave me. So let's jot this down. For the angle side angle, we need two pairs of congruent angles with matching, with matching or congruent sides in between them or in the middle. So over here we have that angle. Sorry, hold on, let me highlight it. We have angle A matches with angle D, and then we have angle B is matching with angle E. So let me write that. Angle A is congruent with angle D. Angle B is congruent with angle E. Now, all we need is that side in the middle. So for us to use angle side angle, we just need to prove that AB is congruent with DE. So if we have those, we can use a angle side angle. So we need side AB to be congruent with side DE. So that's what we need for that one. Okay? All right. And then we're done, right? So a lot of this is knowing what you need in order to answer the question and being able to identify that, right? So I just have two angles. All I am missing is that side, right? That's in between. It has to be in between. Right, so that's your review of these four postulates.